Hello, welcome to our channel Anybody Can Learn. Today we are going to solve questions from 2 to 5 which are based on the concept which I had already explained in our video lecture 1.2. So it's my humble request to all of you to please watch that video for better understanding of today's question. So now let's start. Common data for questions 2 to 5 statement. Consider a point P and a line L that passes through the origin O. So this is a point P with a coordinate 4 and 2. This is a line L that passes through the origin O. The point R lies on the line. This is point R that lies on a line L, and the coordinate of the point R are 1 and 1. Let W is a OR vector, is a column vector with a first entry 1 and second entry 1. OR means W vector. X is equal to OP vector, and it is a column vector with a first entry 4 and second entry 2. This OP is our X vector. Again I am repeating, OR means W vector and OP means X vector. Question 2. Statement. Consider the following statements. Statement 1. The projection of X on the line L is given by X transpose W multiplied by W. Statement 2. The projection of X on the line L is given by X transpose W multiplied by X. Statement 3. The projection of X on the line L is given by X transpose X multiplied by W. Statement 4. The projection of X on the line L is given by W transpose X. So the question is, which of the above statements are true? Options are A. Statement 1, B. Statement 2, C. Statement 3, D. Statement 4, E. None of these statements are true. Let's solve it. So projection of X on a line L is calculated by the formula X transpose W divided by W transpose W whole multiplied by W. Now let us see the statement 1. Statement 1 says that the projection of X on the line L is given by X transpose W multiplied by W. So X transpose W is our numerator and we are multiplying it with a W. So in statement 1 we are not considering W transpose W. So let's solve it. So W transpose means column vector becomes row vector. So W transpose W is equal to row vector 1 and 1 multiplied by column vector 1 and 1. 1 into 1 plus 1 into 1. That means 1 plus 1. So it will give 2. So W transpose W is 2. So statement 1 ignore the denominator. Therefore the statement 1 is false. Statement 2. The projection of X on the line L is given by X transpose W multiplied by X. In statement 2 it multiplied the term with this X vector, but the formula states that it should be multiplied with W vector. Therefore statement 2 is false. The projection of X on the line L is given by X transpose X multiplied by W, but the formula states that the numerator should be X transpose W. That means X transpose should be multiplied by W vector. but in statement 3 it was multiplied with x vector. Therefore, statement 3 is false. Statement 4, the projection of x on the line L is given by W transpose x. But the formula state that numerator should be x transpose W. But the statement 4, it was multiplied with W transpose. So instead of multiplying with x transpose, statement 4 multiplied with W transpose. Therefore, the statement is false. So the correct answer is none of these statements are true. Question 3. Find the length of the projection of x on the line L. Enter your answer correct to 2 decimal places. Answer: the length of the projections is calculated by the formula absolute value of x transpose W divided by norm of vector W. They have given the x as column vector with entry 4 and 2 and W as a column vector with entry 1 and 1. X transpose means column vector become row vector. So x transpose means row vector with entry 4 and 2. Now calculate the numerator x transpose W is equal to row vector 4 and 2 multiplied by column vector 1 and 1. So 4 into 1 plus 2 into 1. 4 into 1 means 4 plus 2 into 1 means 2. So 4 plus 2 means 6. So x transpose W is 6. Now calculate the denominator norm of the vector W. W is column vector 1 and 1 and norm of vector W is calculated by the formula square root of W1 square plus W2 square. W1 means first entry and W2 means second entry. So norm of vector W is equal to square root of 1 square plus 1 square. 1 square means 1. Therefore it is 1 plus 1. 1 plus 1 means 2. So the norm of vector W is square root of 2. Square of 2 means approximately equal to 1.4142. Therefore norm of vector W is 1.4142. So substitute this value in our formula. Formula is that absolute value of x transpose W divided by norm of vector W. Just now we calculated the x transpose W as a 6 and norm of W as 1.4142. So 6 divided by 1.4142 is equal to 4.2426. So our final answer is 4.24. Question 4. Statement: find the residue after projecting x on the line L. Options are A. Column vector with entry 3 and 3, B. Column vector with entry 1 and -1, C. Column vector with entry 4 and 2, D. Column vector with entry 1 and 1. Residue is simply the part of the original vector that remains after removing the projection, and it is calculated by the formula residue is equal to x minus projection of x onto W. X means our original vector. The projection of x on the W is calculated by the formula x transpose W divided by W transpose W whole multiplied by W. They have given the x and W. X is a column vector with entry 4 and 2. W is a column vector with entry 1 and 1. Transpose means a column vector become row vector. Therefore, x transpose is row vector 4 and 2. So calculate the x transpose W. So x transpose W is equal to row vector 4 and 2 into column vector 1 and 1. So 4 into 1 plus 2 into 1. So this will give 4 into 1 means 4 and 2 into 1 means 2. So 4 plus 2 means 6. So X transpose W is 6. Now calculate W transpose W. W transpose is row vector 1 and 1. It is multiplied with a column vector 1 and 1. So 1 into 1 plus 1 into 1. So this will give 1 plus 1 is equal to 2. So W transpose W is equal to 2. Now substitute these values of X transpose W and W transpose W into our formula to calculate the projection of X onto W. So it is 6 divided by 2 multiplied by column vector with the first entry 1 and second entry 2, because our formula of projection of X on W is X transpose W divided by W transpose W multiplied by W. This W is given. So 6 by 2 means 3. Therefore 3 into column vector 1 and 1. So 3 into 1 means 3 and 3 into 1 means second entry 3. So projection of X onto W is column vector 3 and 3. Now substitute this value in our residue formula. So X is original vector. They give the X as a column vector 4 and 2. Now substitute the value of projection of X onto W, that is column vector with 3 and 3. So 4 minus 3 is 1, 2 minus 3 means minus 1. So the residue is a column vector with a first entry 1 and second entry minus 1. Question 5 statement. Find the reconstruction error for this point. Enter your answer correct to 2 decimal places. Reconstruction error is calculated by the formula reconstruction error is equal to norm of vector R square. R means residue vector and norm of R means length or the magnitude of the residue. Norm of vector R square gives the square of the length of the residue. In simple word, reconstruction error means square of the length of the residue. In question 4, we have already calculated the residue, and residue is a column vector with a first entry 1 and second entry minus 1. Now calculate its length. So its length is calculated by square root of first entry square plus second entry square. That means norm of vector R is equal to square root of 1 square plus square root of minus 1 square. So 1 square means 1. Therefore it is a square root of 1 plus 1. Therefore norm of vector R is equal to square root of 2. Remember that norm of R means the length of or the magnitude of the residue, and reconstruction error means square of the length of the residue. So square it. So square root of 2 square means 2. Square root of 2 means 2. Therefore our reconstruction error is 2. Thank you. See you in next lecture.